Not so bad, were they? I now want to move into a few more complex type of examples. These examples are going to include some constraints. I want you to have a go at this next bit of examples. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read sine of 2x is equal to cos of x. The problem with this is, in order to try and get rid of any of the functions sine or cos, they need to be the same function. For example, it's easy to say if sine x is equal to sine of 30, it's easy to say that x is equal to 30 degrees. Right? But they have to both be sine, or they have to both be cos, or whatever. In this case, I've got sine and I've got cos. Now, sine 2x I'm going to leave as is, but cos of x I'm going to make that sine 90 degrees minus x. Because think about this, cos of 10 degrees is the same as sine of 80. So cos of x is the same as sine of 90 minus x. Now I can drop the signs, which means that 2x is equal to 90 degrees minus x. Problem with that, though, is we've still got to include general solution. Why? Think about this. I said that if sine x is equal to sine of 30 degrees, x is equal to 30 degrees. Correct? Almost there, but what if I had sine of 150? Isn't that the same as sine of 30? What if I had sine of 390 degrees? That's also the same as sine of 30. So I've got to include general solution. Because it's the sine function that we've taken out, my one option is 2x is equal to 90 minus x plus k times 360, where k is an element of integers. My other possible solution says that 2x is equal to, what is the other quadrant that deals with sine? The second quadrant, which would be 180 degrees minus 90 degrees minus x plus k times 360 degrees. Again, k is an element of integers. I can solve this. This means that 2x, take that x across, it's going to become 3x is equal to 90 degrees plus k times 360. 3x, I want x on its own. That means that x is equal to 90 divided by 3, which is 30 degrees, plus k times 360 divided by 3, which is k times 120. We've got to divide that into both of those. That's one possible solution. This is for quadrant 1. That's where k is an element of integers. Or 2x is equal to 180 degrees minus 90 degrees plus x plus k times 360 degrees. That x can come across. That means that that'll be 2x minus x, which is just x, is equal to 180 degrees minus 90 degrees, which is equal to 90 degrees, plus k times 360 degrees, again where k is an element of integers, and this is the quadrant 2. The next one I gave you to do read sine of x over 2 is equal to cos of 60 degrees plus x. I'm going to leave the sign x over 2 as that. I'm going to turn that cos 60 plus x into sine 90 degrees minus 60 degrees plus x. Don't let the brackets confuse you. I'm still doing the same thing as previously, except now we've got a whole bracket there. This means that sine x over 2 is equal to sine 90 minus 60 is going to give me 30 degrees minus x. Minus times minus is, minus times a plus is minus. That means that x over 2 is either equal to 30 degrees minus x plus k times 360 degrees, or x over 2 is equal to, what's the other quadrant we work with sine? 180 degrees minus 30 degrees minus x plus k times 360. This is quadrant 2. I'm going to start by getting rid of that denominator. By the way, both of these are when k is an element of integers. I'm going to start by getting rid of that denominator. That means that x is equal to 60 degrees minus 2x plus k times 720 degrees. Minus 2x across means that 3x is equal to 60 degrees plus k times 720 degrees. Let's just take this off for now. That means that x is equal to 20 degrees plus k times 720 divided by 3 is equal to 240 degrees, where k is an element of integers. That's the one possible solution. That's for quadrant 1. If I look at the quadrant 2 solution, remember I said that the quadrant 2 solution is going to be when x is equal to 180 degrees minus that whole thing. So it's 180 degrees minus 30 degrees minus x plus k times 360 degrees. That means that x, that's x over 2. That means that x over 2 is equal to 180 degrees minus 30 is equal to 150 degrees. Minus times a minus is plus x plus k times 360. That means that x is equal to 300 degrees plus 2x plus k times plus k times 720 degrees. X minus 2x is going to give me minus x is equal to 300 degrees plus k times 720. That means that x is equal to negative 300 degrees plus k times 720. Why didn't I change that plus into a minus? Because k can be positive or negative, which means that there's no need to do that. And that's our quadrant 2 solution.